Hello, how's everybody doing today? Hopefully just dandy. Today we're going to be working on simplifying radicals. We touched on it yesterday in the previous lesson, so let's look at what we have today. This is going to be super fast because we touched on it. We're going to look at the first two rules today. We'll look at the rest of simplifying radicals the rest of the week. All right. The first rule is radicals should be multiplied together. So if we have two radicals, we need to multiply them together just by multiplying. So the square root of 3 times the square root of 5 gives us a square root of 15. It's that simple. Here's another example. The square root of 2 times the square root of 3 gives us the square root of 6. Rule 2, a simplified radical is one that does not have a factor of a perfect square. In other words, you must factor the perfect squares out of the radical. This is how we're going to tie in what we did yesterday. So 24, if we did our factor tree, would be 2 and 12, 2 and 6, and then 2 and 3. Well, here's our pair. I don't have a pair for the third 2 or the 3, so 4 is going to be our largest perfect square. So based on what I said above, if we multiply radicals together, they're just multiplying. That means we can split them up as well. So square root of 24 can be split into the square root of 4 times the square root of 6. Well, we know what the square root of 4 is, so we get 2 times the square root of 6. And just like how we treat parentheses, we do not have to write that multiplication sign. So we get our answer there. Let's walk through a couple more examples. Here, 5 times 12 gives us 60. We do a factor tree, we get 2 and 30. We get 2 and 15. We get 3 and 5. So 2 times 2 times 3 times 5. I only have one pair. That must mean it's the square root of 4. 4 times what gives us 60? The square root of 15. So I get 2 root 15. That's my simplified radical. That's as simple as that radical gets. All right, here 3 times 12 gives us 36. Split in half, 2 and 18, 2 and 9, 3 and 3. So we're going to get something a little interesting here because we have 2 times 2 times 3 times 3. Well, if you didn't catch it before, the square root of 36 is just 6. We would catch it now by multiplying all these numbers together. Since they're the pairs, we get 36, which is just 6. For this one here, we're going to bring the tree over here. We have square root of 48. That's 2 and 24. Which is 2 and 12. Which is 2 and 6. Which is 2 and 3. So for here I have 2 times 2 times 2 times 2 times 3. I have a pair, I have another pair, multiply them together, I get 16 with 3 left over. 4 root 3. I know I'm moving quickly. You can slow down this video to watch. However, you can see the steps as I'm moving. Here we want to use our friend, the associative property, and we want to regroup this so that we rewrite this as 2 times 3 times root 5 times root 4. So that we have 6 root 20. If we do the prime factorization of this, you can do it on your own. We get 6 root 4 times root 5. Remember, root 4 is 2. And remember, multiplication is implied there. So 6 times 2 is 12. Root 5 is the answer we get for that last problem. So it says 12 root 5. Hopefully this starts to help you understand why we're going to be using the factor trees in order to simplify radicals. I want to simplify radicals now, even though it comes later in the book, because we're going to be using them through the next couple sections. Good luck with the CYU and the lesson questions.